Hi, welcome to the channel. So in this video, I'll be doing some backtesting with pandas. The idea is to teach you how you can do some backtesting, even for simple strategies. It's interesting to do it with pandas alone. First of all, because you learn how pandas works and how you can get data from Yahoo Finance, but also you understand how everything works. And if you later go and use one of the libraries that make this a little bit easier, you understand how things work internally. The idea is that this approach is useful when you want to do something a little bit more customized or more complex. Maybe if you want to use machine learning or other methods that might not be supported in the libraries that are generally available. And the idea in this example is to just get the data and maybe plot the equity curve and do some performance calculation. And at the end, we'll be doing a heat map with different results. Let's get started. So in this first cell, all I'm doing is just importing a few libraries, define a ticker list that I don't really use, but you can put whatever you want here, and maybe later on try different tickers. So this part of the code just downloads some price data from Yahoo Finance. I'm using 1 day interval, so this is daily data, and at the end I'm getting the close of each stock. So just one detail is that these are adjusted already by splits and dividends, so you don't have to worry about that. So I'll run this cell and this will print this data, pandas data frame that starts from 2005, and I just print a few rows. So this is to show that, okay, well, let's get started with 2005, that we have data of all these stocks. And some of these are stocks, some are ETF, but doesn't matter at this point. So here I'm just selecting the data that starts with this date. And the idea is to do some calculations with this price data. So I'll first select a ticker, so in this case SPY, and I'm just replacing the column name with close, so it's easier to reference later. So in this line, I'm computing the returns, the daily returns. So I'm just calling this R, this new column, and I'm doing close adjusted dot close dot percent change. And then I'm filling with 0 the first row. So this is how this looks so far. So all I did here is just select one of these stickers. So you can see where this is going, right? Later we'll build a function and you'll be able to change the ticker. So all I did here is just I grabbed the close adjusted price and I computed the daily returns. That's simply the percent change of the price between the current day and the previous day. Okay, so let's see how we can compute some simple moving average for this stock. So here I'll be importing the TA-lib. So this is a technical analysis library that makes it very easy to compute these indicators. So in this case, I could have done this with pandas, but I think it's better to show that you can just do talib.sma and you just get your indicator. So the idea of this strategy is, okay, I want to compute a slow moving average that will capture kind of a long-term trend, and then a faster moving average, a fast moving average that will capture kind of like the current price, but it will be less noisy. So the idea is to build a strategy between using these two indicators. So I'll just compute them, and I just want to show you kind of how the logic of this. So here I'm plotting the close price and the slow moving average. So, and you can kind of see that it kind of captures the long-term trend. So this that I'm showing you here is the S&P 500 ETF. So it's a very popular index, so the most popular probably. And it's been doing very well. But there were periods where, such as this 2008 crisis, where it went down more than 50%. So, and this moving average is something that a lot of people use the simple moving average of 200-day period to kind of get a feeling of the trend. So this is the slow one, right? So let's plot the slow moving average and the fast moving average. And you can kind of see that if you zoom out a little bit, the slow moving average looks relatively similar to the price, but it's a little bit less noisy, so a little bit smooth out version of the price. This is kind of the idea, right? So the idea of the strategy would be to go long or buy this index when the fast moving average, so the orange line is above the blue line, right? The slow moving average. And we'll be selling when it crosses down. I mean, you could do a lot of things with these indicators, and you can use more indicators. I just want to use one that's relatively clear, and it's easy to explain. And I think you can learn the others or try them out on your own after you understand how this works. So this is mainly the idea, and let's see how we can code this with Pandas and how we can evaluate the performance. So this is the final one I wanted to show, that plots the close price and both moving average. But yeah, let's continue. So the first thing we need to do is compute the signals. For example, here I have the close adjusted prices, and so far we have the close, the return, and the two moving average. That will be the indicators that we use. So if I do a head here, these two will have missing values because we don't have any information of them. So I'll just filter the data so we have complete data. So if I run this again, we have data for all of them. And what's happening here is the signal computation. So here I'm using, I'm passing the data frame and doing dot assign, and then I'm computing doing this calculation. So basically, if the slow, this is actually the other way around. So it's the fastest. If the fast moving average is higher than the slow moving average, we compute a 1 here. So basically what we're seeing here, right? So if the fast moving average is higher than the slow one, we put a 1, that's the buy signal. Otherwise, we stay out of the market. And this is basically the signal calculation, right? So there's one more step missing because we kind of know this result, this 1 and 0, we know it at the end of the day. So we need to shift this so it reflects that we need 1 day to get that information. So this is what's going on here. So here I put all the code together. So let me comment this out. And basically it's all we did before. So here we have the signal calculation. So the fast moving average is higher than the slow one, otherwise 0. So if I compute this, we get this data for this particular time period where I see that the signal changes. So basically this is for this time period, this is the observation where the fast moving average is higher than the slow moving average. So as we know this at the end of the day, so we actually want that this signal, this 1 is actually 1 in the next observation. So that's what this shift 1 does. So basically I grabbed the signal column and I shifted 1 observation low. So now if I run this again, you will see that this 1 moves down. So, okay, that's kind of the idea. So what we need to do now is to multiply the R, that's the return of the just being long this stock, and we multiply it by the signal. So when it's a 1, we keep this return, otherwise we keep a 0. So this is what's being done in this column. I could have used assign here, but I mean, I don't think it's even needed if it's a very simple expression. So here I'm doing close adjusted.r multiplied close adjusted.signal. So the assign method in Pandas, it's very readable in some more complex calculations, but it uses more memory, so I don't use it always. So basically, now that we multiply the returns and the signal, we get these zeros where we are out of the market. So when the signal is 0, and we get the returns the same as this when we are in the market, right? When the signal is 1. So I picked this date because it's actually, not a long time after the COVID crisis. And this is where this strategy was showing that you had to go long the market. So it was, like around 2 months after the crisis started. So not bad as an idea. So here I'm using 10 for the fast one and 50 for the slow one. But I mean, you can try a lot of these parameters. You will see that they work in some cases and they don't work in some others. So you need to be careful. This is a very simple strategy. You don't want to trade this directly. Okay, so this shows how you can do everything that we've been talking about, from computing the returns, computing the indicators, computing the signal, and then computing the strategy return. So I can put that in a function that has everything, and all I need to do is pass the data. So this is the only thing that I added, that you pass the data, you pass the ticker, and you pass in the numbers of each of these indicators, the parameters. And it returns a data frame with the returns of the strategy and everything we want. So there are many ways we can do this. This is just an example. But the nice thing is that if I call this function, I get this data frame with everything I need. So here's an example of this idea for the same data. And here I'm using the ticker is SPY. So the nice thing is that I can change the ticker here and it would work also. So, okay, so let's see what happens with this, with this strategy. So here I'm saving these results to the F signal, and here we can plot, the total return, and we can actually plot the cumulative return of the strategy. So, and we can see that, with these parameters, it's able to stay away for the most part of the 2008 crisis. So the red line is the return of the strategy, the cumulative return, and the blue line is the buy and hold type of return. So you see it saves you from some pain here and maybe in some other cases. But I mean, it doesn't guarantee that, it will work in other crises. And if you see what happened in this more recent time period, it kind of seems it's not working. So that's why you need to be careful with just optimizing one parameter for all the data. So, but this is, one way you can compute the cumulative return. So what I'm doing here is 1 plus the returns of both of the buy and hold and the strategy. And then I'm doing the cumulative product of that. So that's what keeps adding the returns. Okay, so let's say we want to compute the performance of this strategy in a more objective way, not just look at the chart and see how we feel about it. So just put some numbers to it. And this is what this performance function does. So here I'm passing the F signal, data frame, the stock ticker, a frequency parameter if I want it monthly or daily, and a risk-free rate. So if you know what this means, you have some finance background, great. If you don't worry about it. I mean, risk-free rate means, it's literally explained in the name. It's the risk-free rate. So it's the rate of, a bond that has no default risk. So generally it's thought of the US bonds. So and this for a long time it was very low, and now it increased. So we might need to pay attention to. So 2% might be low for now. Okay, so let's talk about how this works. What I'm doing here. So here I'm just getting the returns of. So R is the buy and hold return, and R strategy is the strategy return. So I'm just renaming these columns so they are more human readable. And okay, so depending on the frequency of that, it's the frequency parameter. So if we're passing a daily frequency, I'm computing a 252. I'm using 252 as a scale. And if you pass a monthly frequency, I use 12. So this is used later on in this function to compute here the annualized returns, the standard deviation, etc. So everything is annualized when we report it at the end. So yeah, I mean, I covered how this works in other videos, so you can check at the previous videos of the series. This is exactly the same code that I used. So basically, the only thing that I added is this Kalmar ratio. And what this does is it does a division between the returns and the drawdown. So the max drawdown. So the max drawdown is the largest drop you experienced during the investment. So you generally want that to be low. And so this division kind of compares the returns you get to the pain that you have to suffer to get that return. So that's why it's interesting. And this strategy is thought to reduce the max drawdown. So that's kind of the idea. So I'm going to run this function. So let's try it here. And we can get some idea of how this strategy did. So here we have the buy and hold returns. So buy and hold did 11% returns, so that's good. And this strategy 9.3. So I mean, it's a little bit lower, but not terrible. But the big difference is that the max drawdown was a lot lower. So here you had to endure the maximum drop was 18%, and here 55%. So I mean, basically, it prevented you from staying in the worst period of the 2008 crisis. And okay, so we can see that the Kalmar ratio is higher because it's basically annualized returns divided max drawdown. And the Sharpe ratio is also higher, which it's dividing the returns and the annualized standard deviation, which is the risk. So basically, I mean, it did well for these with these parameters, but yeah, we need to take it with a grain of salt. So what I'm doing here is running this strategy with multiple parameters. With I define a range of this fast moving average that they are kind of like a less noisy version of the price. So we don't want this to be a lot larger than 50 trading days. 50 is already a lot, but it's fine. So, and the slow one, we want it to be longer. So, I mean, I could even put 300 here. So I don't know, why not? So one condition here is that if the fast moving average is larger than the slow one, we don't want to compute that because it doesn't make sense for this strategy. So I continue, so it kind of goes back into the loop. So we do nothing in this case. And here I'm calling these two functions that we define above. So the df signal, it computes the returns of the buy and hold and the strategy. And here I'm computing the performance. I'm passing 2% for the risk-free rate, and I'm using a daily frequency to convert everything to with the scale I defined. So 252 is the trading days that we have in a year. And okay, I'm also saving the parameters that we have. And this perf tail means that I just keep the last row of these performance results, because I only care about the performance of the strategy. So I don't want the buy and hold to appear everywhere because I already have it here. So okay, I'll run this. Shouldn't take long because this calculation is vectorized, so we're never using for loops. So we can time this. Let's see how long it takes. Okay, so running this loop takes around 3.9, almost 4 seconds, so not a long time. So what I do after that, I just concatenate all the results that appear in this list. So let me show you how this looks. So this has the performance that we computed with these variables and the indicators, the fast and slow indicators, and that's really it. So what I need to do now is maybe make some plots and try to understand which of the parameters are working better. So, so for example, let's say I care about this Kalmar ratio, right? So I want to look for the parameters that generated the largest value. So 10 and 65, 5 and 95. So maybe I can just, pick one of these and then plot the equity curve and see if that makes sense to me. Yeah, and I can also filter by other of these performance metrics. So annualized returns also. The idea in general is that you want to optimize or select a strategy that takes care of returns and risk. So if you only filter by annualized return, it can happen that it's a little bit more risky. In this case, it doesn't happen, but yeah, the results change if you filter by different. So maybe you want the lowest max drawdown strategy. Okay, so the lowest max drawdown is 16%, which is not bad, and it happens with 5 and 70. So okay, and another way to do this is to plot Heatmap, right? So here I'm just defining a metric, I'm pivoting the data, and I'm plotting this Heatmap where I have the slow moving average on the x-axis and the fast one on the y-axis, and I can see in green the highest values of the annualized return. So we can see that the highest values are around here, and yeah, in general, what's on this on the right side of the plot, it doesn't look very good. Yeah, it's kind of red in general or yellow. So we want it to be green for this strategy. But it seems, when the slow moving average is larger than 200, there's nothing very interesting in general. So, I mean, I could go back here and remove that, just put 200 and, okay, and run this again. And I think it's kind of a little bit easier to look at the results now. Okay, and I can also change these variables. So let's put the Kalmar ratio, and this is a little bit different, right? So here we are dividing annualized returns to the max drawdown, and it seems it's the best values are around here. So with the fast moving average between 5 and 10, and the slow one between 60 and 100. So yeah, and I could do the same with the Sharpe ratio also, and see what we get. And it seems it's kind of finding this area that it seems to be better in general. So there's one that's 0.645, but I mean, we don't want to make it depend on just one set of parameters. We want it to be an area of this heat map. That otherwise it's very hard to rely on the results. So you can change these to grow in values of 2 or 1. It will take a little bit longer if you do that, but might be interesting to take a look at the results. And this is where you start saying, okay, maybe I need to make this run faster. There are ways to do that, but in general, it's not worth the effort. But yeah, you can get started like this, and if you need to make it run faster, you can figure out how to do that. But I think as a first tutorial on backtesting, this is relatively advanced and interesting. So yeah, so for example, let's say you want to plot one of these strategies that you see that they are doing well. So let's say 10 and 70 or 10 and 65. So what you would need to do is go back here and compute this, right? So I would say that the fast moving average is 10, and the slow moving average is What did we see here? Yeah, around 70, let's say. So you come here, and then you can plot the equity curve, this total return. Yeah, so this finished. It took like a tiny bit to run, but it will make the plot a little bit more interesting. So okay, so here we have the results for, you know, with one step of like growing of each of these parameters, and it's kind of easier to interpret now, I think, because so here we can see that the best parameters are around this area, but it's kind of, you know, here it's also good. So so here I'm looking at the Sharpe ratio. So let's see what happens with the annualized returns. It's kind of the same thing. So it's around this area. So yeah, it could be the moving average, you know, it could be 9, 10, but yeah, if you go up to 5, it loses some performance. Okay, so let's plot one of these. So there's an area here also that seems to be, yeah, might be even better. So this is interesting. I mean, I wouldn't have thought of this, but yeah, and here we have some area that's also doing good, which is, you know, these two moving average, like a little bit closer to each other. So you might want to, you know, pick a few of these. So let's say you can pick, you know, fast 43 and slow 122. So let's say 43, 122, and maybe plot this. Just print the performance and plot the equity curve. So I mean, it seems that yeah, this has an overall a lower drawdown, max drawdown, and it outperforms during this period, but it underperforms after, you know, 2019. So I mean, no strategy is perfect, but you can see that it prevented kind of this crisis. So it sold here, and yeah, it avoided the 2008 crisis. So I mean, even though it does worse in terms of the returns, it's kind of easier to follow through this strategy than buy and hold. Okay, so let's try this Kalmar ratio. So let's see what we get here. So okay, so this is interesting because the annualized return was kind of telling, okay, you have area here, here, and here, but now it seems, you know, everything that's on this side, on the right side, it's red. So the area to focus is here, which is kind of in line with our original theory, right? With our idea. So so let's see what happens, you know, with one of these, yeah, 6 and 96. So let's try that. 6 and 96. Okay, and we do get the lower max drawdown, and let's see how the plot looks like. Okay, so this looks, I think this looks a tiny bit better, but yeah, I mean, it's kind of more difficult to put some reason why this works better. I mean, it's possible that the fast moving average is just more, yeah, changes, gets in the market faster after a big drop. So it got in here, and it was able to get in after the 2008 crisis. But yeah, I mean, I don't know. You need to decide at some point if you what do you think makes more sense from a conceptual standpoint. But yeah, I mean, this is just one way to think of it. I don't think, you know, there's a lot of in practical terms, there's a lot of value of doing this approach to figuring out strategy, because yeah, I mean, this was valuable multiple years ago, and now people do more complex strategies. It's a lot more competitive. So, but still, I think it's valuable to get started and being able to just get the data and implement this with Pandas. And I think it's very valuable in terms of the learning experience. And if you can do this with a simple strategy, then you can change what happens here, use other models. Maybe you want to try some neural network type of model. You can do that. It's the same idea. So what I think it's always there is how you compute the performance. So there are a lot of ways to do that also, but in practical terms, with this approach, these are generally the most important metrics to evaluate an investment. So yeah, I hope you enjoyed this video. Let me know in the comments what do you think. Thank you very much.